Here is Chapter 1, Part 1 of your test review. Unit rate. Two numbers with different units as a fraction. So $39.42 for 18 gallons of gas. We want to know how much 1 gallon of gas is. So to do that, I'm going to have $39.42 for 18 gallons. So I'm comparing my dollars to gallons. I want to know how much 1 is. To do that, I'm going to cross multiply. I'm going to take 1 times $39.42, which gives me $39.42. Then I'm going to divide that by the only number I have left, which happens to be 18. So if I divide $39.42 divided by 18, I get $2.19 for 1 gallon. Same thing here when we talk about unit rate again, 250 miles in 7 hours. So again, comparing miles and hours. So if I have 250 miles in 7 hours, I want to know how far I can go in 1 hour. So to do this, I cross multiply. 1 times 250 is 250. I divide that by the only number I have left, which is 7. And I get 35.71428.571. So I'm just going to round that to the nearest tenth, which would be 35.7 miles. Always nice to round to the nearest tenth. Here in unit rate, which is the better unit price, $1.99 for 3 ounces bottle or a $2.49 for a 4-ounce bottle. So we're going to compare to see how much each one is for 1 ounce. So the 3-ounce bottle is $1.99 for 3 ounces. We want to know how much 1 is. So we cross multiply. $1.99 times 1 is $1.99. I'm going to divide that by 3. $1.99 divided by 3, and I get 66 cents per ounce. So if I do the same thing here with the $2.49 for 4 ounces, I want to know how much 1 ounce is. I cross multiply again. $2.49 times 1 is $2.49. I then divide that by 4 because it's the only number I have left. So I take $2.49 divided by 4, and I get 0.62 cents. So which of those is cheaper or the better price? That's going to be your $2.49 for 4 ounces. 62 cents is less than 66 cents. Again, talking about unit rate, 153 words in 3 minutes. So we're comparing words to minutes. So it's 153 words in 3 minutes. We want to know how many you can type in 1. Again, I cross multiply. 153 times 1 is 153. I divide that by the only number I have left, which happens to be 3. 153 divided by 3 is 51 words a minute. So here's our complex fractions. Fractions that have a fraction on top, on bottom, or both. So this one here says simplify. So I'm going to take 3/9. Try that again. I'm going to take 3/9 and I'm going to divide that by 4/12. So when I divide, I want to make sure I remember my keep, change, flip. Keep the first fraction the same, 3/9. Change the sign. Change from multiply to divide. I'm sorry, divide to multiply. And flip, we want to flip the second fraction. So the numerator becomes the denominator, my denominator becomes the numerator. So when I do this, I get 12 over 4. When I multiply across, I get 36 over 36, which happens to equal 1. For question 7, here's another fraction on top of a whole number this time. So again, I do the same thing. I take 2/4 divided by 8. I remember my keep, change, flip. Keep the first fraction the same, which is 2/4. Change the sign from divide to multiply. And then flip the second fraction. So 8 as a fraction is 8 over 1. So if I flip that fraction or multiply by the reciprocal, I get 1/8. I'm going to simplify before I multiply. This is where I look at the opposite numerator and denominator and see if they have a common factor. In this case, I know 2 is a factor of 8. So 2 divided by 2 is 1. And 8 divided by 2 is 4. So now I can multiply. 1 times 1 is 1. 4 times 4 is 16. So here's one with a whole number on top and a fraction at the bottom. So again, I'm going to take 4 divided by 3/6. So again, my keep, change, flip. Keep the first fraction the same. 4 as a fraction is 4 over 1. I'm going to change the sign from divide to multiply. And then I'm going to flip the second fraction. So I'm going to move my denominator 6 to the numerator, my numerator 3 to the denominator. And now I can multiply. 4 times 6 is 24. 1 times 3 is 3. Put this in the simplest form, 24 divided by 3, and I get 8 as an answer. Again, complex fractions with unit rates. So the turtle walked 1/8 of a mile in half of an hour. How many miles will a turtle walk in 1 hour? So I have half of an hour. So I know 2 halves equal 1. So 1/2 plus 1/2 equals 1 whole mile. Sorry, that's in an hour. Scratch that. Erase it. Forget what I said. Here I go again. How many miles will a turtle walk in an hour? So I need an hour, so I know a half hour plus a half an hour is a whole hour. Hey, I'm right back to where I started from. So that means I'm going to take 1/8 and add that to 1/8, because this is going to tell me how many miles I am at, which would be 2/8. But if I put that in the simplest form by dividing each by 2, which is the greatest common factor, I get 1/4 of a mile. Number 10 here, it says it took Jenny 2 hours to knit 1/3 of a scarf. How many hours will it take for her to make one whole scarf? So 1/3, how many thirds equal a whole? Well, 1/3 plus 1/3 plus 1/3. 1 plus 1 plus 1 is 3. 3/3 equals 1. So I have 3 of those. So if it takes 2 hours to do 1/3, and 2 hours to do another, and 2 hours to do another, 2 plus 2 plus 2, it would take her 6 hours to make one scarf. Proportional and non-proportional relationships. Proportional relationships will have the same unit rate. So here Jean has $280 in her account. Starting next week, she will deposit $30 in her account every week. So on week 1, she has $280. Week 2, she's going to have 280 plus 30 for 310. Week 3, she's going to have 310 plus 30, which is 340. Is this the same? Well, to find out, I like to cross multiply. So I take 280 times 2, which is 560, and 310 times 1 is 310. Are those two equal? No. Because they're not equal, this is a non-proportional. Number 12 says, at a local music store, CDs cost $11.99, including tax. Is the number of CDs purchased proportional to the cost of CDs? Well, if you buy one CD, you're going to pay $11.99. If you do 2 CDs, you're going to spend $23.98. If you buy 3 CDs, it's going to be $35.97. If you go 4 CDs, that's $47.96. So to see if this is proportional, let's cross multiply. Let's take $11.99 times 2, which would be $23.98. And then if I cross multiply again, 1 times $23.98, I get $23.98. Are those two equal? Yes. So in this case, we are proportional. That is it for part 1. We're going to jump right into part 2 to cover the back half of this chapter. So on this side, we're talking about which situation represents a proportional relationship. Remember, it has to have the same unit rate. So when I look at a team A, I know 0 and 0, okay? 2 and 6. Well, what can I multiply by 2 to get 6? That would be 3. Does that work everywhere? Is 0 times 3 0? Yes. Is 4 times 3 12? Yes. Is 6 times 3 18? Yes. So in this case, 1 minute is 3 feet. That is proportional. In team B, 0, I can't multiply anything to that. So if I add 4, if I add 4 to 2, 2 plus 4 is 10? No. So this is not proportional. Team A is, because it has the same unit rate, which means I'm always multiplying by 3. It says which size syrup in the table has the lowest unit price. So again, we're going to try each one of these and find the unit price to find out how much 1 ounce is. So in the golden syrup, I have 704 over 32. So I want to know how much 1 is. So 1 times 704 is $7.04. I divide that by 32. 704 divided by 32, that is 22 cents an ounce. If I look at brown gold, I take 480 over 20. I want to know how much 1 is. So 1 times 480 is 480. I divide that by 20, by the only number I have left. And that would be 24 cents. Let's look at silky syrup. That's $5.52 for 24 ounces. We want to know how much 1 ounce is. So again, I cross multiply. 5.52 times 1 is $5.52. I divide that by 24. 5.52 divided by 24 is 0.23 or 23 cents. So far, golden syrup is the best buy. Let's look at Aunt Mabel's syrup. Aunt Mabel's is $7.28 for 28 ounces. How much for 1? We cross multiply. 1 times $7.28 is $1.28. I'm going to divide that by the total number of ounces, which is 28. And it's also the only number I have left. 728 divided by 28 is 0.26 cents. So of all of these, which is the cheapest? That's going to be 22 cents, which is going to be the golden syrup. So it says Joe can jog 1 1/3 miles every 1/4 of an hour. Find his average speed per hour. So again, if I look at this, it wants per hour. So how far can he go in 1 hour? Well, I know 1/4, that my denominator is 4. So if I have 4 1/4, that gives me 1 hour. So I need to take 1 1/3 and I have to multiply that by 4 because there's 4 of those. Let me go back. Move my eraser back here. So I'm going to take 1 1/3 times 4. So I'm going to change 1 1/3 to an improper fraction. So I take 3 times 1, which is 3. I add that to my numerator, which is 4. My denominator stays the same, which is 3. And I multiply that by 4 over 1. When you multiply straight across. So 4 times 4 is 16. 3 times 1 is 3. I put that improper fraction into a mixed number. 16 divided by 3. 3 goes into 16 5 times with 1/3 left over. So in 1 hour, he can go 5 1/3 miles. The table shows the cost of ordering a certain number of donuts. Donuts, love donuts. What are the missing values if the cost is proportional to the number of donuts ordered? So I know that there's $12 donuts for $3. So what can I do to 3 to get 6? Well, I know that 3 times 2 is 6, so I do the same thing up here. 12 times 2 is 24. And also find the unit rate, which is 12 to 3, and how much is 1 donut. Cross multiply, you get 12. 12 divided by 3 equals 4. So you get 4 donuts for $1. So if I have 9 donuts, there's 4 donuts for $1. And I have $9. How many donuts can that be? If I cross multiply, 9 times 4 is 36. Divide that by 1, that is 36. What if I have 48 donuts? How much is the cost? So again, if I have 4 over 1, 4 donuts for $1, and I have 48 donuts, I cross multiply. 1 times 48 is 48. I divide that by 4, and I get $12. As long as they're proportional, you can use a cross multiplication method and divide to help you solve for those. Here we have which graph best represents a proportional relationship. So which one shows that it is going up by the same each time? So in this case here, I pick out any 2 points. So this one here is at 2, 7. So here would be 4, 10. So 2, 7 to 4, 10, which means it's going up and over, up 2, over 3. Okay, over 2, up 3. So if I go here and I find a point, I'm going up 2, I'm sorry, over 3, up 2. So that is proportional as well. But the only thing about this one being proportional is that it's going down. And proportions don't go down, they continue to go up. So that one doesn't work. Here, there's no clear, there's 0, which means that it would go over, but that's not proportional either. Here, we're at 4, and we get up here to 10, so we're going over 1 and up 10, sorry, up 6. So if I go over 1, 1, 2, 3, 4, 5, 6, that one's not proportional either. This is your proportional graph. So solving proportions using cross multiplication. Hey, this is what I've been doing this whole time. So when we take a look at proportions, we're going to cross multiply and divide by the only number left. So here's a variable, so I can't multiply 9 times that, so I'm going to multiply 4 times 8, which is 32, and I'm going to divide that by the only number I have left, which is 9. 32 divided by 9 is 3.5 repeating, and that equals W. Same thing here. I'm going to cross multiply. 11 times 2 is 22. I divide that by the only number I have left, which is 5. 22 divided by 5 is 4.4, and 4 and 4/10 equals G. So by using unit rate, ratio tables, or a proportion, solve the following. So the manufacturer of M&M candies states that there are approximately 210 candies in a 7-ounce bag. How many candies would you expect to find in a 10-ounce bag? So we're talking about candies and ounces. So if there's 210 candies in a 7-ounce bag, we want to know how many candies would be in a 10-ounce bag. So again, we can set up our problem and then cross, multiply, and divide to solve this proportion. 210 times 10 is 2,100. And I'm going to divide that by 7. And when I do, I get 300 candies. Would be in a 10-ounce bag. So what is the constant rate of change shown in the graph? So what is it doing? So here's my x value. My x goes left to right. My y value goes north and south, right, up and down. So if x is 2, y is 80. If x is 4, y is 160. And if x is 6, y is 240. So to find our rate of change, we want to go how much is 1. So if it goes up 80 for every 80 miles in 2 hours, how far would it go in 1? So again, 1 times 80 is 80. I want to divide that by 2. It's the only number left. So that means it would go up 40. So if this increases by 2, 40 times 2 would be 80. So if I add 80 to each one, it should be the same, which it is. So my rate of change is either 1 for 40 miles for 1 hour would be my rate of change. So here we want to find out what the slope of the line from the table below. So to find our slope, I'm going to use my formula of y2 minus y1 divided by x2 minus x1. So here's my x value, here's my y value. So here's x1, here's x2, here's y1 and y2. So y2 would be 80 minus y1, which is 40. And I'm going to divide that by x2, which is 4, minus x1, which is 2. 80 minus 40 is 40. 4 minus 2 is 2. And 40 divided by 2 is 20. That's where your slope is at. It's a great little tool to help you use to help you find that slope. Our last one is direct variation, constant of a proportionality. So to do this, I take, here's my x value, is my number of hours, y is the number of cookies. I'm going to use the symbols as y divided by x. So I take 15 divided by 1, and that equals 15. I try the next one. 30 divided by 2 is 15. 45 divided by 3 is 15. Notice that the constant of proportionality is 15, because they're each multiplying by 15. 1 times 15 is 15, 2 times 15 is 30, 3 times 15 is 45, 4 times 15 is 16, and 5 times 15 is 75. This is your review for Chapter 1. Good luck on your test on Monday.